All right, so I'm going to be recording the answer to another question on the slide. This is a new question that I added since I posted it, but what would the potential difference VC minus VB? So we're looking at this section across the resistor. So this is the resistor here. If the battery EMF is 3.5 volts, so we can see that our battery is right here, and we can look at what's happening to delta V as we're going through this circuit. So we're going to assume the electric field in the thick wires is very small. And the question we want is, do we have enough information to get the current I? Okay, so before I move this to start working it out, there's one thing I want to point out from the way the question is written to what we actually see. So here it says you can assume the electric field in the thick wires is very small. However, we can see that that's not entirely true. If we look at this graph, we can see here and here, which is what corresponds to the thick wires, that there is actually a delta V. So you want to actually use this graph and not make this assumption, even though the question has set you up to do that. So, okay. What we're going to do is we're going to use this graph to answer the question. So, and we're going to look at delta V across connecting wires. So we know that going through the circuit plus the EMF of the battery is going to be 0. And if we look at this, we can safely just kind of make a rough estimation. We're going to estimate that VB minus VA is approximately the same as VD minus VC is approximately minus 0.5 volts. So we can see they've got a negative slope here. We know it's going to all add up to 3.5. So this is kind of the one hand wavy portion. All right, so now that we've made that estimation, we can start using loop rule to go after the solution to this problem. So we have VB minus VA plus VC minus VB plus VD minus VC plus VA minus VD is equal to 0. And we had said that these two are equal to minus 0.5. So then we have minus 0.5 volts plus VC minus VB plus minus 0.5 volts plus that battery, 3.5 volts, so that's the battery right here, is equal to 0. So we get that VC minus VB is equal to approximately minus 2.5 volts. So the delta V across the resistor is about 5 times the delta V across connecting wires. But we actually don't have enough. We need to learn a little bit more about resistors, because current is I equals NEA UE. And we can rearrange to put this in terms of delta V over L. So NEA U delta V over L. We don't know these properties about the resistor. And so this is leading into what we're going to do in chapter 19. Not enough. Not enough info for I.